Hi, this is Austin with Sprint 4, the optimized collision system. So I'll go ahead and show it first because I have all the collidable group AABBs being illustrated. So you can see that all the collision enemies are in one big group. You can also see the new enemy I added here, who just chases me at my speed and just tries to crash into me, unlike the other ones. Boom, boom. Also, these guys, as you may notice, don't shoot when they're too far away to actually hit you anymore. I thought that'd be a nice thing to add, so I went ahead and did that. So, these two enemies are pretty much done as far as I'm concerned, but, so there's my collision system. And the two completed enemies on the game end. So, let's take a look at the actual code for the engine, that is. This is all the same, but then down here is the process collisions. This is where it loops through to compute the AABB for each one. You can see that because it's in process collisions, which is before it calls all the collision commands, that this will only be being done once per frame, so that should be good. The actual collidable group code for calculating the AABB. So first of all, if the group's size is 0, then it just doesn't calculate that AABB, and that's because of the way that I have the group of collidable groups set up. Is that some of them aren't going to have anything in them, so I don't want to calculate AABBs if I can't, obviously, and then just loops through like it does with the regular AABB, finds the min and max, and then calls compute data on that, and that's just a new function I added that I'll show you in a moment. So, in that sense, the display command. So the actual code I added here was I added one that would calculate the data for the AABB based on the B-sphere, just using the math we talked about in class. It shouldn't be anything too surprising. And then this one takes 6 floats, which is just the min and max z's, and just sets those for the min and max. So that way the AABB can be created directly by the collidable group afterwards. So there's that. Collidable, let's see here. Oh, right, so the thing with the collidable is that it now has a default sphere, which gets calculated when the collider model is set, and if it chooses to use a B-sphere, then it just uses that sphere. And it'll always update this with whenever update collision data is called, it'll also update the sphere in addition to the regular volume. And then the visualizer, this is just something I fixed from last week so that I could actually do this in one line without using a temp. So there's that. So next I'm going to look at my two files from last time. So here's my whole plan for I'll get to look at this one first. The whole plan for the game. So most of this I decided to keep with a few minor changes. Like I'm going to need to redo the model on the tank in order to have a separate turret. I don't think that's too big of a deal. As you can see, I already the health now stays the same between scenes as well. That's something I forgot to mention, but it's in there. And then the default enemy and the kamikaze enemy are both done. So that remains the boss enemy and then a spawner for the kamikaze enemy that I want for one of the levels. I want to implement the leading bullets that we talked about in class with a FSM to check whether or not the player's been moving for a while, and if so, then it'll jump to using leading bullets rather than directly targeting the player. And then various things blow up should make particles appear. Once I get it working on one, it should be easy to get it working on all of them. Make a model for the bullets, still the same. And then an observer pattern in the tank so that I can only shoot 4 bullets at a time, so I can't just spam as many bullets as I want. Terrain, obviously, is this coming week, so that shouldn't be anything surprising. I want the player and enemy to snap to the terrain rather than remaining upright. I don't know if that's part of the sprint or not. Hoping it is, so I don't have to do that separately, but if not, I have it built into one of the sprints, I think. Yep. Next, this is the same, and then this is all the same as well. And this is mostly just me drawing some bad art. So none of this should really take that long, aside from actually designing. I still need to design the terrain for the 3 levels, but I have the plans for like having the boss and the 2 kamikaze enemy spawners in the last level, and then my sprint plan is here. So design train maps and then the boss and enemy spawners will be my plan for next week. So this should correspond with the sprint itself, and then this is my extra work that I want to do. So implement the shooting limit like I talked about, snapping to the terrain if it's not part of the prior sprint. If it is, then I can probably get some of this done in that sprint instead, but I'll get there in a moment. Yeah, merge in the personal project here, because right now it's a separate project still. And I'll also look at that in a moment as well. But build the models, yada yada. Finite state machine like I talked about, and then implementing the particle system once it's done. So next up is the personal project plan, and this is this should cover everything that I want to put in there as of now. So anything that I mentioned like back on week 2 that's not in here is just it's scrapped unless I have time, unless I have extra time to work on it. So I have reading and writing the file. I have that done. I'll show that in a moment. That's also done. And then a lot of this stuff is the same, but I have like an actual proof of concept here to demonstrate kind of what I was talking about with some of the things. So for example, you seem confused about the idea of having like a separate data storage class. So essentially the idea I have here is like, what if the enemies have a bunch of pointers that I'm not going to be easily able to read from a file. So what I do is I instead store that data in this data storage class, and then write that, serialize that instead, as shown here. And then, once everything quote-unquote dies, then I will recreate those. I will have the spawners recreate the enemies normally, and then read the data from the data storage class, rather than trying to directly serialize the enemy. That way I can just have the spawner take care of the pointers normally. So that's what I was thinking with that. I have verified, by the way, this all works, so after everything's deleted and then recreated, and I get the data from the buffer, it does correctly recreate the enemies. I wasn't planning on going through to show that. I'll go ahead and push this to Perforce, I suppose, if you really want to take a look, but it does work. So, and then last but not least is the actual project that I did this week. So last time I had it so that you could do it, you could save and load in-game. Now you can quit out of the game and go back in, and it'll still work. So I'll go ahead and start the actual game and push this guy over like I did last time. And this should probably be about far enough to get the point across. So I go to pause like I did last time. It serializes everything. Now I'll hit backspace, and nothing's going to happen on screen, but that should save everything to a file. And I will go ahead and escape out. Start it again. And I will hit 2 this time. That's my load game button. And that guy will still be over there. So there it is. It now is no longer only in-game. And the code for that is here in the priv read and priv write files, and then the start hack is what takes care of that. So, and then as you can see in my storable test, I no longer have the redundant storage class. I just keep the buffer in the storable manager. There actually is one thing that I forgot to mention, which was this. You questioned the necessity of this, and my rationale was that if the enemy is about to shoot right before you save the game, then when you load the game, the enemy should still be about to shoot. So I'm not actually storing the entire alarmable object, just to be clear, but I do think that it would at least be necessary to store like an array for the 3 alarms of what time each alarm should fire, so that it can recreate the alarms appropriately. And then possibly something like that for the inputable as well, in case the player enables hitting the enter key, for example, midway through the game. Then you need to save that and load that as well, because it might not, the regular load, or the regular generation of the object might not handle that. So that was my rationale for that.